Okay, in this little short note set, we're looking at working with compound inequalities, and this is part of Algebra 2, Section 1.4. It's the last page, page 4. Now, I'm actually going to back up to the previous problem, and we already filled in most of this already. So here we are at the bottom of what would be page 3. This particular note packet down here says page 15, but anyway, the page numbers are not as important. It's the fourth page or the third page of the 1.4 notes. Okay, so we're supposed to graph this compound inequality, and the operative word is and. And with an and statement, it has to be true and true to equal true. So if either one of them fails, the whole statement fails. So we're going to start with the left-hand statement, and we're going to add 1 to both sides. And then we'll divide by 2. So we found out that x has to be bigger than -3. So we're looking, first of all, for numbers that are to the right of -3. And these same numbers have to meet the second criteria. We'll find out what that is. Divide both sides by 3 here, and you find out that the second criteria that has to be met is that the numbers are less than or equal to 1. So you would ask, are there any numbers that meet both descriptions? So let me get a little scale going here. And we're looking for numbers that are to the right of -3 and also to the left of +1. So I'm going to go ahead and show you which ones work. Open circle at the -3 and a closed circle at 1. And the numbers that are to the right of this one and to the left of that one are the ones that are in between. So really this becomes an in-between statement. Now these and statements often do turn out to be in between. There are some that don't. But you are expected to write this in a consolidated fashion. Put it together as one. And when you consolidate this, you put the variable in the middle with less than signs on both sides. Don't ever use anything. Don't use a greater than sign, okay? So I'm going to say or equal to on this one, and you put the smaller of these two numbers on the left and the larger one on the right. And this is the shortcut way of writing what's on the line above it. To maybe make that a little more clear, I'm going to highlight the x is less than or equal to 1 in both of them. And there's also, now the word and is not written here, but there's also x is greater than -3, which is written here just in backwards fashion. X is greater than -3, you could also say is written here, -3 is less than x. Now I'm going to reiterate this. When you do these in-between signs, you put the variable in the middle with less than signs on either side. In this case, a less than or equal to. But you don't mix less than and greater than signs in these examples. Okay, now we actually are on page 4. And this time we're going to be using an or statement. You can see that we've got the word or there. And or statements are more lenient. They're considered to be true if A is true or B is true. So you could have true, and then here you could have true, and that would be true. Or you could have one of them true and the other one false, and it's still true. The only time this is false is when they both fail. Okay, so we'll divide by 2 here. and that lets us know we want numbers that are less than 3. Then there's this operative word here, important, write that down, or, and then I'm going to add 5 to both sides. Okay, so I need a number line here with a scale on it. I'll start with 0 there. I'm going to just tell you that you need a scale, which is evenly spaced marks, and at least 2 numbers indicating where 2 of the tick marks, their values are. You also need to use a straight edge, not freehand. Okay, so let me graph the numbers that make this true. All I have to do is find numbers that make this true, or both true at once. So the numbers that are less than 3, they work. The numbers that are greater than 8, they're also fine. And there's no place where both of those are true at once. But let me give you the place we didn't shade. I'll pick this 6 as an example here. 6 right there. 6 is not less than 3. And 6 is not greater than 8. So that's why it's not shaded. It failed both tests. The OR statement is true when either of them is true. Okay, a little bit more on that in-between format that we talked about on the previous page. In-between in math looks like 2 less than signs with a variable in between. Let me explain. So here I've got 2 things that are true with an AND statement between them. The number 4 is less than x, or you could say x is greater than 4 to the right of 4. And here we have it's to the left of 7. So the numbers that are to the right of 4 and less than 7, let's go ahead and put a scale on here. They have to be both to the right of 4, and they have to be to the left of 7. And I've done that wrong. To the right of 4 and to the left of 7. Well, that would be the numbers right in here that meet both criteria. Now, this is the exact same statement. It's just done in 2 parts. Now, I can kind of illustrate that by doing the following. This part here would be the left-hand side of it. And this side here is the right-hand side of it. And the word and is not shown, but it's implied. So a less than sign on the left. Just a second here. And another less than sign on the right. And that's an in-between statement. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7. And I'll go one more. And we're going to circle the 4. And we'll circle the 7. And this x value is sandwiched between them. It's bigger than one and smaller than the other, so we'll just shade that area in between. Okay, so this in-between statement, and here you're going to see that I used a less than sign and a less than sign. You never mix those. It's always less than signs on both parts. We're going to solve this inequality. 3x plus 13 is in between -2 and +22. We're going to solve that by first of all subtracting 13 in all 3 parts of this inequality. And on the left we get -15. The middle part, the 13's cancel. And then on the other side we get 9. Then we're going to divide everything by 3 to get rid of that 3. And that'll give us what we wanted, which is the x in the middle. And it's going to be between -5 and +3. Now this or equal to means we can count the 3. It's part of the answer. So let me get a scale going here. Here's -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. I have my scale on there. It's usually a good idea to put 0. And we're talking the numbers that are between -5 and +3. +3 is included, so you saw me shade that little dot. And everything in between there is an answer. Okay. Quality control problem here with something called a tolerance. What it is it tells you how much bigger or smaller the part can be and still be valid and work in the machine in which it was that it was designed for. Okay, so it tells us the ideal part should be 4.82 centimeters and that it has a 4/100ths of a centimeter tolerance. So you could go a tiny bit higher or a tiny bit lower. Now, the lathe operator got it down to 4.91, which is bigger than the ideal, and is still out of tolerance. In other words, it has to be closer than that to be right. So what we're asking here is if he takes this 4.91 centimeter part, puts it back on the lathe, and takes off a little bit, that has to be between the low end of the ideal size, so 4.82 minus the tolerance, and 4.82 on the high end plus the tolerance. So that leads us to 4.78 on the left. And we have the expression 4.91 here. And then on the other side, you get 4.86. All right, so what I'm going to do here is I'm going to subtract 491 from all parts of it. 4.91 minus 4.91 and minus 4.91. That'll take me to, let me see what that gives. I'm subtracting on my calculator here. Negative 0.13. And the other one turns out to be negative 0.05. All right, we still don't have x in the middle. We've been trying to get x in the middle. What we're going to do is divide by -1 here, which lets us know we have to turn the inequality backwards. So it's going to be x, and these things now point the other direction. 0.05 and 0.13. All right, you're better off flipping this around since in between should have less than and less than. So I'm going to pick this up end for end and reverse the flow of it. Okay, so he can take off anywhere between 1/2 of a centimeter and 13/100ths of a centimeter and still have a part that will fit in the machine. And that does it for the 1.4 notes.